The Parker Solar Probe passed through a coronal mass ejection. NASA's Parker Solar Probe has flown through one of the most powerful coronal mass ejections ever recorded. Instruments on board the spacecraft captured the entire event, giving scientists a closer look at the interactions between coronal mass ejections and interplanetary dust, which could improve future space weather predictions. The Parker Solar Probe, launched into space in August 2018, passed through a coronal mass ejection (CME). A CME is a cloud of plasma emitted by the Sun and accelerated to enormous speeds in the solar corona. These types of events can affect space weather. The ejection of material from the Sun towards Earth could endanger satellites, disrupt communications and navigation technologies, and even destroy power grids. The Parker Solar Probe flew through the CME on September 5, 2022, but the analyses of the data sent to Earth took some time and their results were only recently published in the Astrophysical Journal. During the analyses, it turned out that the probe had hit one of the most powerful coronal mass ejections ever recorded. This was a dangerous situation for the probe itself, but also an incredible opportunity to investigate this type of event using scientific instruments mounted on Parker Solar Probe. The CME flyby helped prove a 20-year-old theory about how these events interact with interplanetary dust. A 2003 paper proposed the idea that CMEs could interact with interplanetary dust in orbit around our star and even transport dust long distances. Obtaining new data on these events could help scientists better predict how quickly CMEs may travel from the Sun toward Earth, better predicting space weather. The concept of interactions between the CME and interplanetary dust was proposed 2 decades ago. But the interactions themselves were only observed when the Parker Solar Probe detected that the CME was acting like a vacuum cleaner, removing dust from its path, said Guillermo Stenborg, an astrophysicist at the Johns Hopkins Applied Physics Laboratory in Laurel, lead author of the publication. It was engineers and scientists from this university who designed and built the probe. They also handle missions. Interplanetary dust consists of particles of asteroids, comets and other space debris and is present throughout the solar system. During the recorded CME, this dust was blown about 10 million kilometers from the Sun, about 1/6 the distance between the Sun and Mercury. The blown-out dust was replaced almost immediately by new dust coming from the areas next to the passing CME. The spacecraft's in situ observations were crucial to this discovery. Characterizing dust dynamics following CMEs from long distances would be quite a challenge. The probe landed on the CME at a distance of 9.2 million kilometers from the surface of the Sun. Fortunately, the mass ejection was not directed at Earth. Studying the physics behind CME interactions with interplanetary dust could have implications for space weather prediction. Scientists are just beginning to understand that this dust influences the shape and speed of CMEs. However, further research is needed to better understand these interactions.